Yesterday we have studied some SAQs from ray optics, right? So today we'll study what is formation of rainbow from ray optics only. After that, one question from wave optics also will take. Okay. So first, formation of rainbow, you see. Formation of rainbow. Rainbow, you know, it is the 7 colors of arc. 7 colors of arc, right? So generally, during when rain is falling, and also sunlight is coming from sun. So at that time, what happened? The sun rays passes through the rainy droplets or water droplets, which are remain suspended in the atmosphere for small duration of time. So due to this water droplets suspended in the air, when sunlight is passing through the atmosphere, they passes through water droplets also or raindrops. So when they are passes through raindrop, you know, rain means water drop. So water is a medium. Light coming from where? Air. So that means rarer medium to denser medium is coming. But we know when light comes from sun, it comes as white light. White light. When it is enter into any other medium, it's split up. This white light will be split up into different wavelength. Different wavelength in which we are able to visible 7 colors or 7 wavelengths. That only WIB-GR we call. That means in formation of rainbow, first phenomena takes place is dispersion, splitting of light. Dispersion of light will be takes place. Second, and this dispersed light will passes inside the raindrop. Okay, like if you take so this is a raindrop. Raindrop. Okay. So sunlight is coming from here like this. This is a sunlight. Sunlight. Okay. And as is enter into raindrop, it split up. So like violet color and red color. That is dispersion of light takes place. Then from this surface, which is falling on this, because here dispersion takes place and it is falls here, and such a angle they will fall greater than critical angle. Greater than critical angle. So yesterday we have studied when ray of light falls greater than critical angle, it reflect back. Internally reflect will takes place. So from this internal reflection will be takes place. Like this. This is red, this is violet. And from this refraction will be takes place. Like this refraction will be takes place. Here red color, this is violet color. So if it's similar rainbow, one more rainbow if you take here, one more raindrop. So as usually there is a sunlight falls like this. Sunlight. So it split up violet, red color. So from this violet, so here somebody observer is there. For him, these two will be received some angle 40° and this angle 42° will be received. That means first raindrop red color, from second we'll get violet color. So this kind of rainbow in which red is above, violet will be below. So this is basically formation of rainbow. In this basically three different phenomena takes place. One is at this particular point A. Second, this is a particular point B, and this is a particular point C. A, dispersion. B, internal reflection. C, refraction of light. Clear? So during formation of rainbow, first dispersion takes place at A and internal reflection at B. Okay. And finally, refraction at C. Then the rays are reached to observer as shown. During formation of rainbow, first dispersion, that is splitting of white light ray into 7 colors at A, and internal reflection at B, finally refraction at C, then rays are reached to observer as shown in the figure in this way. Clear now? There is this kind of rainbow is called primary rainbow. Primary rainbow. There is a secondary sorry. There is a secondary rainbow is also there, in which nothing is there. Dispersion as usually takes place. Internal reflection also takes place. But from here, whatever we are getting internal reflection from here, it will internally reflected back to here. And from there again, one more internal reflection will be takes place. One more internal reflection will be takes place. Okay. So 2 times internal reflection, 1 time dispersion, 1 time refraction will be takes place. But in primary rainbow, 1 dispersion, 1 internal reflection, 1 refraction will be takes place. So only the difference between primary and secondary will be primary rainbow dispersion plus internal reflection plus refraction and order of colors red to violet. Red to violet. In secondary rainbow, dispersion plus 2 times internal reflection and plus refraction as usual. That means what? Only one more time extra internal reflection is taking place in secondary rainbow. Due to that, order of colors are reverse. Order will be violet to red color. Violet to red color. Order will be violet to red color. That is reverse order will be get. Is it clear? Formation of rainbow is a combination of dispersion, internal reflection and refraction. That will be takes place as shown in the figure. In primary rainbow, red and violet will be order of color, red to violet. In secondary, because of one more time internally reflection taking place, due to that, order of color will be reverse. Order of color will be reverse. So in this way, we can say the formation of rainbow. ये लाइन नहीं आ रहा है. ये लाइन जो है डिस्पर्शन प्लस 2 टाइम रिफ्लेक्शन, इंटरनल रिफ्लेक्शन प्लस रिफ्रैक्शन एंड ऑर्डर V2R. ठीक है, जिसको नहीं दिख रहा है ये डिस्पर्शन प्लस 2 टाइम्स इंटरनल रिफ्लेक्शन प्लस रिफ्रैक्शन एंड ऑर्डर इज वायलेट टू रेड कलर. वायलेट टू रेड कलर. बस बस. Clear now? Any doubt, students, on this question? Any doubt? Okay. So next we'll move on to the next question. From it is wave optics. From wave optics SAQ only again. That is, what is Doppler effect in light and difference between red and blue shift. Red and blue shift. Okay. So we'll see now. Okay. So we'll see now from wave optics. Question is, what is Doppler effect in light? And difference between red and blue shift. Red and blue shift. Simple question only. What is Doppler effect? So basically, Doppler effect is because of there should be a motion between observer and source. Observer and source. So here we are discussing Doppler effect in light. The source means source of light. Source of light. Like a source of light means what? Stars. Generally, stars. So the relative motion between observer and source of light. Due to this relative motion, there is a change in frequency or wavelength. Frequency or wavelength. This change in frequency or wavelength due to relative motion between observer and source of light is called Doppler effect. Okay. So what is Doppler effect means? So like, studied in sound chapter, like when train is approaching towards a stationary observer in railway platform and the train is moving away from stationary observer from railway platform. So there is a difference in the frequency of sound will get. So this only Doppler effect in sound. Same way, their source of sound means train. So same way in light also, when stars are moving, okay, an observer is observing that. So the relative motion between observer and source, there is a change in frequency and wavelength. This is called Doppler effect. Correct? So the change in frequency and wavelength due to relative motion between observer and source of light. The change in frequency and wavelength due to relative motion between observer and source of light is called Doppler effect. So from this we can write the expression for that. The fraction of change in frequency we can write delta f by f. F is a frequency and minus v by c we can write. Minus v by c. And from this v is the observer's v is the speed of source. And c is the speed of light. Okay. And v is positive for source moving away, negative for towards. Obviously away it is positive, mean towards will be negative. Now look here. V is positive for source moving away means V is positive means this will be a negative only. That means delta F we are getting negative. That is final frequency minus initial frequency, we are negative we are getting. Final frequency minus initial frequency, difference in frequency negative means what? Final frequency smaller than initial one. Final frequency smaller than initial one. That means when source of light moving away, frequency reduces or frequency decreases. So frequency decreases means we know speed is equal to frequency into wavelength. Speed of wave. Speed of wave is equal to frequency into wavelength. As frequency decrease means obviously wavelength should be increased. Wavelength should be increased. That means I can say when source is moving away, frequency decreases, then obviously wavelength will increase. Or when source is moving towards, frequency increases, then wavelength decreases. So, what is Doppler effect in light? This is a Doppler effect. Then what is the difference between red and blue shift? Basically, in VIBGR, visible light, we can able to see from violet to red color or blue. Lower wavelength, higher wavelength red and lower wavelength violet. So whenever due to relative motion or whenever due to this Doppler effect, if source is moving away, we know that frequency decrease, wavelength increase. Wavelength increase means initial wavelength compared to initial wavelength, the wavelength of final will be increases because of Doppler effect. Increases. Increase means what? The wavelength is going to higher order. Wavelength is going to higher order. That means in VIBGR, higher order color will be up to red color. Towards red is a higher. And towards blue or violet is a lower, we call. Towards red is higher, towards blue or violet is lower. So as when source is moving away, wavelength is increases. Okay. And this wavelength shift towards higher wavelength. That means towards higher wavelength means towards the red color. That's the reason it's called red shift. And when source is moving towards, frequency increase, wavelength decrease. Due to this, what happened? Wavelength decreases compared to initial wavelength. Final wavelength decreases. Decreases means what? It is lowered. Lowered means towards blue color or violet is moving. So we can say it is going towards lower. So we can say it is blue shift. Clear now? Red shift means it is a it is occurs or it is due to increase in wavelength. It is due to increase in wavelength. Okay. So difference you want to write here. I can write here red shift and here blue shift. Okay. It is due to increase in wavelength. Increase in wavelength. And simply it is due to decrease in increase in wavelength, decrease in wavelength. Correct? Next, it is due to increase in wavelength, it is due to decrease in wavelength. Next, why it is increase in wavelength? Because source is moving away. Source is moving away. Here, red shift due to source moving away. And same thing here, blue shift due to source moving towards. Source is moving towards. So this much is enough for writing answer for this question. The simple Doppler effect is a change in frequency and wavelength due to relative motion between observer and source of light. Then the fraction of change in frequency delta F by F and minus V by C, where V is the speed of source, C is the speed of light. And V is positive for source moving away, negative for moving towards. Then I told because of source is moving away or towards, either wavelength increase or wavelength decrease. Increase in wavelength shift towards red, decrease in wavelength shift towards blue. That only we call red and blue shift. So increase in wavelength is because of source moving away, decrease in wavelength due to source moving towards. That only here, red and blue shift. Is it clear, students? Is it clear? Yeah. So now we'll go to the next chapter, next question. So which is from electrostatics, electric charges and field. From electric charges and field, the question is state and explain Coulomb's law. Coulomb's law. State and explain Coulomb's law or Coulomb's inverse square law also they can call. Coulomb's inverse square law also we can call. Clear? So what is basically Coulomb's law means? This Coulomb's law is basically related to charges. So we know there are two types of charges will be there called plus and minus. Plus sign, minus. And we know that two positive charges or two negative charges, they repel. They repel. And two plus sign minus or minus sign plus charges means unlike charges, opposite charges or attract each other. They attract each other. So between any two charges, based on their nature, whether like or unlike, both are same nature or both are opposite nature. Depends upon that, between them, either repulsion force or attractive force will be present. Repulsion or attractive force will be present. And that force only we call Coulomb force or electrostatic force we call. And to find the magnitude of electrostatic force and direction, by using this law we can find how much force exists between them. How much exists, that you can find by this law. Clear? So we'll see now how it is possible. So first statement will write. Statement of the law. Law, what is statement means? The attraction or repulsion force between 2-point charges is directly proportional to product of their charges and inversely proportional to square of distance between them. Distance between them. Directly proportional to product of their charges and inversely proportional to distance, square of distance between them. And it acts along the line joining them. The line along the line in which they are joining them. So along that line, this force will act either attraction or repulsion. Clear now? So this statement. Then what is expression or explanation? Simple, you see. For example, so let us consider 2-point charges are kept apart by R as shown. Okay. So देखो यहाँ पे एक में पॉइंट चार्ज Q1 लिया, ये यहाँ पे एक पॉइंट चार्ज Q2 है, दोनों प्लस प्लस चार्जेस है एंड दोनों के बीच में जो R डिस्टेंस है, ठीक है ना. सो यहाँ पे दोनों पॉजिटिव पॉजिटिव चार्ज है तो दे आर रिपेल ईच अदर, दे रिपेल ईच अदर. So what is mean by repel? Suppose the force on this first charge due to second charge, because the second charge will exert force on first and first charge also exert force on second one. So this is force on 1 due to 2 and this is force on 2 due to 1 because repulsion both are correct. And this is act along the line joining only, straight line only, the force of direction. Correct. For example, if you take one minus charge and other plus charge you take, they will attract each other, right? So Q1 is attract towards Q2, Q2 will attract towards Q1. That means this attraction force will be like this. But both the situation, whether it is attractive or repulsion, both forces are in opposite direction. And both forces equal in their magnitude. Equal in their magnitude. I can write here F12 magnitude is equal to F21. That is commonly we can take F. Okay. Or otherwise F21 is minus of F12, direction wise opposite, magnitude wise equal, or and F12 magnitude F21 magnitude commonly I'm taking as F. Okay. Now coming to the as per the definition of this or statement of the law, attraction or repulsion force between them 2 point charges is directly proportional to product of their charges, inversely proportional to square of distance between them. Correct? So for that, what I can do, so this F magnitude of force directly proportional to product of their charges. Product of charges, two charges we have, Q1, Q2, and inversely proportional to square of distance between them. That is R square. Then from this directly, if you cancel the proportionality, get some constant, and that is 1 upon 4 pi epsilon naught Q1, Q2 by R square. Clear? And here epsilon naught is constant. Permittivity we call of air. Permittivity of air. Clear? So this is what you call explanation and the expression for Coulomb's law. Is it clear, students? हाँ वही सेम लिख दिया ना, वो F1 to F2 एडिशनल आया बस उतना ही सेम वही लिख सकते, वो स्टेटमेंट लिख के लिखना. Clear now? So next, one more question from the same chapter, that is Gauss law and its importance. Gauss law and its importance. The question is, state Gauss law and write its importance. State Gauss law and write its importance. This is a question. Same. So we should state the law, and then after what are the importance or what are the applications. state the Gauss law, write its application or importance, both are same only. Generally, what is Gauss law means? So Gauss law is really giving to find an electric flux through any closed surface, through any closed surface. So this law is very useful to find an electric flux through any closed surface. And we know when flux you calculated, so from the flux, we can able to find the electric field also. Electric field. That is basically we can find the electric flux and we can find an electric field from using this law. Okay. So actually, what is the Gauss law? What is the Gauss law means is saying that the net emerging flux, जो भी जो flux आ रहा है, flux means electric field lines, number of field lines. So the number of field lines which are coming out of the closed surface, per unit surface, perpendicular surface area, that flux emerging from any closed surface is equal to 1 by epsilon times of total charge enclosed in the surface. मतलब जितना चार्ज सरफेस के अंदर है वो पूरा के पूरा चार्ज बाय एप्सिलॉन नॉट, उतना एमर्जिंग फ्लक्स उतना एमर्ज हो सकते हैं। कोई भी क्लोज्ड सरफेस से जो फ्लक्स आ रहा है which is exactly equal to the total charge inside by epsilon naught. That is, just now I told epsilon naught is the permittivity of air or free space बोल सकते। So according to that, what is statement means? The net emerging flux from any closed surface is equal to 1 by epsilon naught times of total charge enclosed in closed surface. For example, I have +1 Q1 coulomb is there. There is minus Q2 coulomb is there. There is a plus Q3 coulomb is there. And there is Q4 coulomb is there. Okay. यहाँ पे Q4 लिखेंगे, ये Q3 है यहाँ पे। So एक गॉसियन और एक क्लोज सरफेस है, मैं ऐसा इमेजिन किया, ये क्लोज सरफेस है, closed surface. Okay. So as per the statement, total flux emerging from this closed surface equal to total charge inside by the epsilon naught, correct? So as per the definition, flux net pi net is equal to integration of E dot dA, A means small area, or ds, you can write ds, will be equal to Q enclosed or Q in bolte, Q enclosed by epsilon naught, correct? But as per this diagram which we have considered, integration of E dot ds is equal to enclosed charge कितना, यहाँ पे Q1, Q2, Q4, Q3 है, 4 चार्जेस है, बट क्लोज सरफेस के अंदर कितना है, Q1 माइनस Q2 Q4, इतना ही चार्ज अंदर है, एक Q3 बाहर है, बाहर वाला नहीं लेना है, बाहर वाला side charges should not be included in this equation because as per the definition the total charge inside only, जितना चार्ज अंदर है वही लेना पड़ेगा, करेक्ट? तो इसलिए ये Q1 माइनस Q2 Q4 लेना है, Q3 छोड़ देना, So मतलब as per this statement, I can write here Q1 minus Q2 plus Q4 by epsilon. वैसे एक example है ये. Clear ना? ये statement हो गया, इसका equation हो गया. So अभी important लिखेंगे. What does importance? What is importance mean? First, it can be valid for any kind of closed surface for any shape and size. Any shape and size. It is मतलब ये जो क्लोज सरफेस है ना, कोई भी शेप हो सकता है, बट इट शुड बी क्लोज होना चाहिए. उतना ही कंडीशन है, क्लोज होना चाहिए. और वो कोई भी साइज भी हो सकता है, शेप भी कोई भी हो सकते हैं और साइज भी कोई भी हो सकता है, बट इट शुड हैव it should close. It should be closed. That's it. So whether shape is anything or size be anything. So that means it is valid for any shape and size of closed surface. Okay. And we can find electric field due to symmetric bodies. Symmetric charged bodies. Okay. And finally, this can also valid whether these charges are inside or moving or stationary. Both the case, it can be applicable. मतलब ये law can be applicable whether charges inside are moving or at rest, stationary or moving. Both cases, this law can be applicable. So it is valid for stationary and moving charges also. But condition, it should be inside. Okay. So these are few importance of the Gauss law and the statement of the Gauss law. Is it clear? Clear, na? So these are two questions, little bit easy only because no mathematical equation, much more involved, and simple statement and the equation, statement and equation. That's it. Clear? So this is, so today we have learned 4 SAQs, one rainbow, other red shift, blue shift, Doppler effect in light, and Gauss law and Coulomb's law. Clear now? So rest of things will continue tomorrow. So if you have students, any doubts regarding today class, you can ask now. Any doubts are there, you can raise your hand. Yeah. Tell me what doubt you have. क्या हुआ? Rahul. Students, any doubts? Shall I end the session? Okay. Tomorrow we'll see. Okay. Doubts is there, you can ask.